Hello everyone, welcome back to the YouTube channel of Pepcoding. So right now we are going to discuss another interesting question on the linked list, that is the reverse linked list pointer recursive. So let's try to understand what is the problem statement. So here in this question we are provided with a linked list like this: 1, 2, 3, 4, 5, 6 and 7, and we need to reverse this linked list. We know that each linked list have some data like head, tail, size. So what will the size? Let me assign some address to each node. So it has 10k, it has 20k, it has 30k, it has 40k, 5 has 50k, it has 60k, and it has 70k. So we know that this head will be holding the address of the first node, that is 10k. Tail will be holding the address of the last node, that is 70k, and size will holding the number of nodes, that will be nothing but 7. What we need to do in this question is we need to break these links and need to create new links so that my linked list get reversed, and we need to perform this recursively. Okay, similarly here what I need to do, I need to break this link and 6 start pointing to 5. I need to break this link, 5 start pointing to 4, 3 break this link, 4 start pointing to 3, need to break this link, 3 start pointing to 2, break this link, 2 start pointing to 1. Earlier 7 was pointing to null, but now 1 start pointing to null. Here you can see what I have made this. Now the last thing is 7 will become the head and 1 will become the tail. Okay, let me change here the addresses. Now this head will become the 70k and the tail will become the 10k. You need to perform this. Just try to solve it by yourself. After that we will discuss its solution. Okay, so I hope you have tried it by yourself. Let's try to understand it from the beginning. Okay, so what I said, we are provided with a linked list like this: 10, 20, 30, 40, 50 and 60. Let's keep it short. Okay, each node have some addresses: 20k, 30k, 40k, 50k, 60k, assuming it. Okay, and each node each linked list have some data, some properties. Okay, we know that head, tail and size. Earlier the head was 10k, tail was 60k, and the size was 6. We know that. Okay, so how will approach to this problem? We know that we need to solve it recursively. So how I'm gonna solve this problem is I'm going to use the recursive stack, or we know that we need to use the recursion for this question, but let's figure out how we will solve it using the recursion. Okay, so what I'm going to do, I'm going to call my next I'm going to pass my next each node next to the recursively to the same function. What I'm going to do now, at first I will pass this 10k, I'll pass this 10k node, and this 10k node will say that I will recursively call my next to the same function. This 10k calls 20k. Actually we are passing the address, calls 20k without performing anything, without doing anything. We are just recursively calling to the next function. Next we are calling to the same function with the node.next. So this 20k is calling to the 30k without performing anything. Okay, 30k calls to the 40k, 40k calls 50k, 50k calls 60k, and 60k calls to the reaches to the null. Okay, so we know that whenever a base condition arises, we need to backtrack from that side. So from here we start backtracking. We know that during the backtracking we get a chance to iterate each and every node in a reverse manner. Means now we are here, we have a chance, now we have a chance to iterate to iterate each node from here, from here and from here. Okay, we have a chance to iterate from the backward direction, and during the backtracking we will update its links. Okay, I hope you get it what I'm trying to say. Now the question arises that how we will update our links. Okay, the first thing which I'm going to say is whenever the last means the extreme case arises, means whenever I reach to the tail pointer, just ignore it. But when I reach to the node which is whose next is tail, means when I reach to the last second node, just update its pointer. Now think about how we will update it. Okay, so the last second pointer will say that I am nothing, but my next to the next will be nothing but me itself. Okay, during recursive calling, it will say that my next to the next will be nothing but me itself. So how the link get created? This link get destroyed and such type of link get established. Okay, my next to the next, so itself next to the next will be nothing but self itself. Similarly, 40 will say that my next to the next will be nothing but me itself. So this link get break and this link get established. Okay, self next to the next will be nothing but self itself. Similarly, 30 will say that my next to the next will be nothing but me itself. This link get break and this link get established. Similarly, this link get break, this link get established. But but here, when we reach here, 20 will 10 will say my next to the next will be me itself. But here you can see this 20 to 20, 10 to 20 link is not break till now. Okay, so here is a loop. If we don't update update this 10 next with a null, then this will create a loop and it will access like 2010 2010 2010. Okay, so at last what we need to do, we need to break this loop by ourselves and we need to make this 10 to point to the null. Okay, so let's try to code it till now and we'll figure out the last step at the during writing the code. Okay, so we are going to write the code on the Pepcoding portal. Here is a function. So what we are going to do, we are going to take the help of the reversePRHelper function to carry out this task. Okay, we're going to call this function with the help of this dot head. Okay, this function is also going to call itself on node dot next to. Okay, this function will call recursively itself again and again, and if the base condition arises, means if it reaches the out of bound, then we need to tackle it. We will say that if this node will become null, then do nothing, just return from that case. Now, as I told you during the explanation time, that if we reach at the extreme most node, means if the node is tail, then do nothing. Okay, if node equals to tail, then do nothing. Okay, but if the node that we are accessing is not tail, then this node will say that my next to the next will be nothing but me itself, and we keep on doing this for all the nodes. While coming from this function, means while backtracking from this function, we need to update the head. Okay, how will update the head? We'll make the head dot next with the null, because if we don't update it with the null, then what happen, a loop get created and it will keep on iterating over the same loop. Now the only last thing which is left in this function is that we have not swapped the tail and the head. Means the tail is still pointing at the last of the linked list, head is still pointing at the beginning of the linked list. We need to swap them. We need to make tail pointing to the beginning and made to point the head at the last, tail at the last. Okay, what we do, node temp equals to head equals to tail equals to head. Okay, let's try to run it. There is a compilation error. Okay, semicolon is left somewhere. Let's see. Okay, here also the semicolon is left. Okay, here semicolon is required, and now let's try to run it again. Okay, we are getting the wrong answer. Let's figure out why. Okay, we are updating tail with the head. No, we need to update tail with the temp. That's why we are getting the wrong answer. Okay, so yeah, it is accepted. Let's try to submit it. So it is correct. Okay, so I hope you get this solution. If you don't get this solution, that means your recursive concept is not as clear. So just go and watch the video of the recursion, and the link is in the description. So if you like this video, don't forget to hit the like button, subscribe to our YouTube channel, and share this video with your friends. Till then, stay safe, stay healthy.